My name is Yurta Hariharanamwai and I'm a freshman at University High School. My science fair inquiry project is called Bye Bye Microcephaly, and it's about creating an mRNA vaccine for the Zika virus. When I first started researching for a science fair project idea, I stumbled across something called microcephaly, a condition where a newborn's head is abnormally small. I was especially interested in its connection with the Zika virus and was surprised that there was no vaccine for the virus yet. This led to my problem statement. Is there a way to create a vaccine for the Zika virus so that it reduces the risk of microcephaly in children whose parents contract it? I started this project with some basic background research. Zika is spread by two different types of mosquitoes, Aedes aegypti and Aedes albopictus. It can stay in your body for up to 1 year after you are infected by it, and the worst thing about it is that it can be sexually transmitted. Zika mutates ANCL2, a gene responsible for the fetal brain development and also impacts the proliferation of other brain cells, like oligodendrocytes. This info helped me start my journey towards proving my hypothesis, which is, I think that creating a viable mRNA vaccine for the Zika virus is possible because of previous successful mRNA vaccines created for viruses. For my project, I used one computer and one brain, mine. For my procedures, I started out by researching the basic background research of what Zika virus is and how it causes microcephaly. Then I researched how mRNA vaccines work, and then how COVID-19 and the new influenza mRNA vaccines were created. Then I created all the approaches I could think of for the Zika mRNA vaccine, finalized the approach I wanted to take, and then outlined the approach. mRNA vaccines work by injecting virus RNA into the cells in the body that replicate it. When these fake proteins are detected by the body creates antibodies to fight them. This is how COVID-19 vaccines are built. The newly created influenza vaccine is similar, but contains the mRNA strands for all 20 known subtypes of the flu, providing the patient with a baseline level of immunity for new mutations as well. Once the antibodies are created and the fake illness runs its course, the mRNA is destroyed. There was one DNA vaccine created in the past for the Zika virus, and though it was successful in animal trials, it never made it past the testing stage. I found out that Zika affects the brain in both fetuses and adults by latching onto axonally receptors and injecting its genetic material into glial cells, disturbing and eventually stopping the development of oligodendrocytes, which are responsible for myelination of neurons, and a lack of them contributes to microcephaly. My vaccine targets the axonal receptors by replicating the Zika virus surface E protein and induces a fake immune response to it in order to create antibodies. My outline will also prove my hypothesis, because if this vaccine is injected into a pregnant patient, the antibodies resulting will cross the placental barrier, and the fetus will be immunized as well, making it less susceptible to Zika and ready to fight it when Zika comes. From this project, I learned that while research like this can be hard and tiring, it is also extremely rewarding. Though there were many dead ends in my journey to figure out how to create this vaccine, I had just as many small victories, and that really kept me going throughout this project. I was fascinated to learn about the way Zika worked, and even more excited to find ways to combat it. I have not found any other studies that cover the material mine does. For that reason, I'm excited to make this into a real vaccine one day. But for now, thank you for listening. Bye!